Well, this video number 7.5, or halfway between 7 and 8. What I showed you in 7, this circuit's been running now for about 45 minutes. Let me show you the voltmeter on this NiCad battery. We're at point, you can see it's charging still, a little slower, 0.919. We want to get up to 1.325, that'll be full charge. So it looks like it's not going to take all that long to charge this 700 milliamp hour battery. Let me pull a magnifier down in here so that I can show you what's taking place inside the cell. And you can see the extreme amount of gas coming from that one element set up there. And over here, you can't discern it as clear because of the fact that this coil, I messed up here. I put this in and it hadn't been conditioned yet. It has to run for a considerable amount of time to get all the oil and gunk off of it. And then it won't cloud up the water like we're getting now. But these two coils here, are fully conditioned, and they're not producing any garbage, they're only producing gas. Now this one here, you can see that it does have bubbles formed on it. It's kind of hard to see the fine ones coming up off of the center post. Once this is fully conditioned, then we won't have that problem with the water getting so messed up. And I think it's probably a pretty good time also to show you what I'm using for wire. The stainless steel wire I'm using is called a safety lock wire. Let me turn this light off here just for a second. It's a safety lock wire which is used for locking bolts, pins, things like that. It's readily available, it's inexpensive, it's 302, 304 stainless steel. You can get a pound of it. It's by Wire and Cable Specialties Incorporated. It's 1.04 millimeters in size. It's quite stiff, of course, because it's stainless. It's quite strong also. You get a pound of this for probably about $10–15. And it works quite well for doing various types of electrode configurations. I have a whole paper that's no longer available to the public, though, on how you would shape particular electrodes, coils versus V's versus triangles, etc. Did a considerable amount of work many years ago on that. But anyway, this battery is continuing to charge. We're at 0.919. Our current into it has dropped to 18 volts, 38 mils, 600 milliwatts. Now, you've got to realize that is not what's going into the battery. That's what's going into the entire circuit. And as a result of that, we're only pulling off a small portion of that into charge current for that battery, and there's a whole lot of it being utilized right here in the production of this gas from that cell. And also we have a little bit of wasted energy in this LED here. The transistor runs cold. When I say cold, it does not produce heat. It does not go below ambient, though. Let me correct that. So the transistor runs at room temperature. This LED, which is common on the exciter boards, is quite bright, as you can see. We have a considerable amount of gas that's coming out of this one set of electrodes, and we have enough gas coming out of here to where you can see that we are definitely having current flowing between those two electrodes, and that's what's charging that battery. So anyway, I wanted to update that. What I'll do is, after this particular arrangement takes that battery up, I may or may not come back and show you a discharge curve on it. The battery is old, as I said in video 7. I'm not sure it'll hold the charge, but I'll get it up there and give it a shot anyway. If not, we'll just go ahead and on tape number 8, we'll go ahead and move right into the capacitor, which will be a lot easier to make sense of. Over.